of functional relationships. Each graph shows distance as a function of time. One graph shows the function when Mr. Dia is driving in his neighborhood. The other graphs represent Mr. Dia driving on major city streets and highways. Which description matches each graph below? So what you're going to do for this lesson for today is you're really going to be looking at the different slopes of the lines and then matching them up to the three different driving speeds that he would have. So the first one he had was when he was driving in his neighborhood. The second one was driving on major city streets, and the third one was driving on highways. Well, as you know, just in general, driving through a neighborhood would be really slow. So the slowest speed should be driving in the neighborhood. The highest speed would be the highways. Which makes the mid speed the middle speed we'll say will have to be the major city streets. Okay. All right. So the highest speed is going to be there from highest to lowest. So then you would know our highest speed is going to be the one with the greatest slope. The slowest speed would be the lowest slope or the least slope. Which makes the middle speed be the one in the middle, of course. Midpoint. Alright, so then we'll just go ahead and look at these. So the first one, we see that within 1 hour, he's driving 30 miles. And I know it's 1 hour because on the x-axis, it's representative of time, and the y-axis is representative of distance. So in 1 hour, so this 130 means that Mr. Dia is driving 30 miles per hour, which makes 1,40 in graph B be 40 miles per hour. And 160 is 60 miles per hour. And all we have to do now is just put them in order from greatest to least. Our greatest slope is graph C, which is 60, so that's going to be our highway speed, or his highway speed. The lowest slope was 30 miles per hour, and we said the least slope would be the slowest speed, which is 30 miles per hour, and that's Mr. Dia driving in his neighborhood. And finally, we have the middle speed, which was 40 miles per hour, and this is going to be Mr. Dia driving on the city streets. Find out more. The graph to the right shows Mr. Dia's drive to work. This is called a qualitative graph because it describes a function visually, not with exact numbers. So go ahead and highlight or underline this on your paper as well, if I can go ahead and do that. So a qualitative graph describes a function visually, not with exact numbers. Very easy. The sections labeled A, B, and C have the same slope as the graphs with the corresponding letters on the previous page. Qualitative graphs can have sections with horizontal segments. In this case, the horizontal segments here mean that there is no change or movement. So that's important as well. The horizontal segments mean that there is no change or movement. This might mean that Mr. Dia stopped somewhere along the way. Now we're seeing that he stopped somewhere along the way here. That's our horizontal section. In the horizontal section, we'll say that it may represent a stop or no change in movement. meaning that this person stopped. Okay, moving on. Qualitative graphs can also have curved lines to indicate the slope or rate of change, and it means that the slope is not constant. It's very important. So a curved line means that there's no constant rate of change. All right, moving along. The graph to the right shows the number of students who are in the school cafeteria between 11 a.m. and 1 p.m. on one school day. Students go in and out of the cafeteria without following any pattern. The rate is not constant, so there is not a linear situation. Remember when we talked about linear relationships, it has to be a straight line. Okay, that line could be diagonal, it could be horizontal, any of that. But if it was curved, then it's non-linear. So of course, since this line is curved, it is a non-linear function. Okay? Okay, moving on. The graph shows the following. So this curved graph shows these two things. The number of the students in the cafeteria builds gradually until 12 p.m. So let's look at that. So looking until 12 p.m., which will have to be in the middle, right? So if I cut it down about here, and we can clearly see that it's going up, okay? Or it's going pretty much over, right? But then between 12 and 1, so again, between 11 and 1, we have 12. Between 12 and 1, the students in the cafeteria decreases because it's going down. All right, that's super easy to see. So you see that from 11 to 12, the number of students is increasing, and then 12 to 1, it's gradually decreasing. And we can see that it's gradually decreasing because it's still pretty high here, and then it starts to kind of go down. All right, that makes it a gradual decrease. All right, so then go ahead on your paper and answer the reflect question.